Introduction.
Adam, which team do you think will most likely win this game? I think most likely the blue team will win this game. The red team had to be prepared to be disappointed, Ali. You're laughing now, but I think the red team will make the best of it and probably win the game. What do you think the chances are for the red team to win this game? I think it is 60-40. I think there is a 70% chance that the blue team will win. Why do you say that? Why do you think that the blue team will have the biggest chance to win? 3 of the players in the blue team are actually the school players. In that case, I'll change my prediction. I think the red team has a 50-50 chance of winning the game. You're giving them a bon parfait chance. Okay, let's wait till the end of the game to find out whether my prediction is right.
Hello. That was Adam and Ali discussing about which team will most likely win the basketball game. They're using words such as most likely, probably, chance, and prediction. In our daily life situation, we often use these words to predict the occurrence of certain events. Do you still remember the definition of an event from our previous lesson? Today, we are going to learn more about the events in the theory of probability. What is the actual meaning of the event in the English language? An event is something that happens, especially something important, interesting, or unusual. In our daily life, we can classify events as events of certainty, events that may happen, and events that will never happen. Let's look at some examples. Let's look at the Earth. We can see that the Moon is moving or orbiting around the Earth. It's an event that is happening and will certainly happen. Our examples of events that will certainly happen are the month of December having 31 days, and the product of 2 negative integers is a positive integer. Can you think of any other event that will certainly happen? Now, we will look at the events that will certainly not happen. For example, we know that the sun always rises in the east. It will never rise in the south. So the sun rising in the south is an impossible event. Other examples of impossible events are a goat laying eggs and all of us having 28 hours a day. Can you think of any other impossible events? In mathematics, and more specifically in the theory of probability, an event is a list of all outcomes in the sample space of an experiment which satisfies certain conditions. And as we have observed in our previous lesson, an event is a subset of the sample space. In probability also, any given event can be possible or impossible for a sample space. Let's now explore more about the possibility of an event happening in an experiment. First, we will learn how to determine whether an event is possible for a sample space or not. An event is possible for a sample space if it is a subset of the sample space and not an empty set. In other words, the elements in that event are also elements of the sample space. Let's do example 1. 3 musicians are chosen from a group of 4 men and 2 women. Now we will determine whether the following events are possible or impossible for the sample space. The first event is 3 men are chosen. 1 man, 2 men, and 3 men. So it is clear that the event 3 men are chosen is possible for the sample space. In this example, 3 musicians are chosen from a group of 4 men and 2 women. The second event is 3 women are chosen. 1 woman, 2 women. There are only 2 women in this group. We can see that the event 3 women are chosen is impossible for the sample space. The third event is 2 women and a man is chosen. 1 woman, 2 women, and 1 man. The man can either be the first man, or the second man, or the third man. We can see that the event 2 women and a man are chosen is possible for the sample space. Let's continue with the example 2 on how to determine whether an event is possible for a sample space. Consider the experiment. A pair of black shoes and a pair of red shoes is placed into a drawer. If Alia chooses 2 shoes randomly from the drawer, determine whether the following events are possible or not. The first event is 1 red shoe and 1 yellow shoe are chosen. There are 2 red shoes in the drawer, so it is possible that a red shoe is chosen. But there are no yellow shoes in the drawer, so it is impossible that a yellow shoe is chosen from inside the drawer. Hence, this event is impossible for the sample space. The second event is 2 shoes of different colors are chosen. The first shoe chosen is black and the second shoe chosen is red, or the first shoe chosen is red and the second shoe chosen is black. This event is possible for the sample space because there are 2 different colors of shoes available inside the drawer. The third event is of 2 green shoes are chosen. There are no green shoes in the drawer, so this event is impossible for the sample space. Remember the video that we watched earlier? Ali thinks that the red team has a 60-40 chance of winning the game. On the other hand, Adam thinks that the blue team has 70% chance of winning the game. What do you think they mean when they say 60-40 chance or 70% chance of winning? 60-40 chance of winning also means 60% chance of winning. Ali may have seen the red team winning 3 out of 5 games or 6 out of 10 games before this. 3 out of 5 or 6 out of 10 is equal to 60%. Similarly, Adam may have seen the blue team winning 7 out of 10 games before this. So from their observations or database, they predict which team is most likely to win the current game. So, this is what we are about to do right now. We are going to find the probability of an event happening by observation or by collecting a database about that event. We are going to find out how many times an event occurs out of a number of times we try the experiment. In other words, we are going to find the ratio of the event occurrence to trials. Now, let's see how we can find the ratio. For example, a dice is rolled 10 times and the results are as shown in the table. From 10 tries, 6 outcomes result in even numbers. So the ratio of the number of even numbers to the number of trials is 6/10 or 3/5. The rest of the outcomes are odd numbers. Hence, the ratio of the number of odd numbers to the number of trials is 4/10 or 2/5. What if we increase the number of trials to 50 or 100 or 1000 or even more than that? Will the ratio still be 0.6 for getting an even number and 0.4 for getting an odd number? Let's find out. First, key in the number of trials you want for the experiment. Key in a big enough number, for example 100, 1000 or 10,000, and then click on the Start button. What can you observe about both ratios for getting even numbers and odd numbers when rounded to 1 decimal place? Do the numbers tend towards a constant? Can you determine that constant? What can you observe about the ratios of each outcome in the table? Do you notice that the numbers also tend towards a certain constant? What is this constant? Write down this constant in your notebook because we will refer to it in the next lesson. You can click the Reset button to reset everything and try this experiment again. Let's try another experiment. This time we are going to toss a coin. First, key in the number of trials you want for the experiment. Again, key in a big enough number, for example, 500 or 5,000 or 50,000. Then click on the Start button. What can you observe about both ratios for getting heads and tails when rounded to 1 decimal place? Do the numbers tend towards a constant? Can you determine that constant? Write down this constant in your notebook because we will refer to it in the next lesson. You can click the reset button to reset everything and try this experiment again. The activity that we have just done is actually to find the probability of certain events when rolling a dice and when tossing a coin. The probability of an event is defined as the ratio of frequency of the event to the total number of trials from a big enough number of trials and is denoted by capital letter P. Let's go through the example shown here. A survey was done to determine the number of students in a college that owned a motorcycle and a handphone. From the 2,400 students involved in the survey, 1,080 of them owned only a motorcycle each, and 720 of them owned both a motorcycle and a handphone each. If a student is randomly chosen from the 2,400 students, the probability that a student owns a motorcycle is 1,800 over 2,400, or 3 over 4. If a student is chosen randomly from the students who own a motorcycle each, the probability that a student owns a handphone is 720 over 1,800, or 2 over 5. Now we will continue with the second example. In a group of 2,000 participants in a walkathon competition, 1,200 are men. Let's assume that each participant has an equal chance to win this competition. If a participant is randomly chosen from this crew, the probability that the participant is a woman is 800 over 2,000, or 2 over 5. The probability that a man will win the competition is 1,200 over 2,000, or 3 over 5. Summary. Today we have learned that a possible event is a subset of the sample space. On the other hand, an impossible event, which is an event that will never happen in an empty set. The probability of an event is the ratio of the frequency of that event to the number of trials.